Hello guys, welcome back. So here we have another question from GATE EC 2018 on network theory. So for the circuit given in the figure, the magnitude of loop current in amperes correct to 3 decimal places, zero point 0.5 seconds after closing the switches. So this switch is closed at t equal to 0, let's say. And if the current is some I of t, they are asking I of t at t equal to 0 0.5 seconds. And here if you see there is an inductor, they haven't given any initial condition for the inductor current. So we can take it to be 0. And this circuit is similar to a first order RL circuit, right? So based on initial and final condition of I of t and the time constant, we can arrive at the equation for I of t with respect to time. Okay. So here we already have the initial condition. So because I of 0 minus is equal to I of 0 plus due to an inductor, this is equal to 0 amperes. What happens at I of infinity? So if we take this circuit, so for t greater than 0, this is the circuit, right? So at t tending to infinity, what happens? This will be in steady state and this will be shorted. So what will be your I of infinity? Your I of infinity will be 1 volt by 2 ohms, which is equal to 0 0.5 ampere. So we got the initial and final condition. We want to find the time constant. So for RL circuit, what is the time constant? Tau is equal to L equivalent by R equivalent, right? So here L equivalent is nothing but 1 Henry. What is the R equivalent? So here if you see 1 ohm and 1 ohm are in series. So our R equivalent will be 2 ohms. So what is the time constant then? It is 0 0.5 second. So now we have I of 0, let's say just 0 is 0, I of infinity is 0.5 and tau is equal to 0.5 seconds. So how will the I of t graph look like? Initially it is 0 and finally it goes to 0.5 ampere. So since it is a first order RL circuit, the I of t can only take this path, right? And it is of some exponential nature, minus t by tau. So my I of t is nothing but 0 0.5 should be the final value. So at t equal to 0, it should be 0. So I'll write it as 1 minus e power minus t by tau. So if you see at t equal to 0, this exponential becomes 1. So 1 minus 1 becomes 0. Similarly, when t tends to infinity, this term goes away and whatever is here will appear as it is. So this is your I of t equation. Now we want to find at t equal to 0 0.5 and at tau is also 0 0.5. So what is I of 0 0.5 is? It's 0.5 into 1 minus e power minus 1. So e power minus 1 is, you can use a calculator, it is 0.368. So it will be 0.5 into 1 minus 0.368, which is 236.0. So this is nothing but 0.632 divided by 2. 0.5 is nothing but 1 by 2. So this is 0.316 ampere. So this is your I of t answer. So 0.316.